There are lots of triangle properties, and we've covered a few of them thus far, and today we're going to cover a few more. Something you might have noticed about triangles, though, specifically in the context of pizza, comes in a square box, it's a round pizza, comes with triangle slices. Hopefully our properties will be a little clearer than that confusing reality. The angles of a triangle. The angles of a triangle, one really important property that you should know, the angles of a triangle always will add to 180 degrees. And if we know that the angles of a triangle add to 180 degrees, we can use this fact to find missing angles on triangles. For example, on the left here, I've got a triangle with a 22, a 64, a 67, a y, and an x, and we want to find both x and y. Well, if we focus for a minute just exclusively on the large triangle that's on the outside, we know that triangle has to have 180 degrees in it. It's already got a 67. Then it's got this top angle that's made up of both a 64 and a 22. 64 and 22 combine to be 86 degrees. And then there's this mysterious third angle, and I shouldn't mark them the same way. There we go. Third angle of x. But what we do know is all three angles have to add up to 180 degrees. The 67 plus the 86 plus the x have to add up to the 180 degrees. And so to solve, first we'll combine 67 plus 86, figure out what that is. That's 153. Plus x has to equal the 180 degrees. Well, to get the x alone, we'll just subtract 153 from both sides. And now x is equal to 27 degrees. So x is a 27-degree angle. But we're not done yet because we've still got to figure out what y is. Now you'll notice the y is part of a different triangle. Y is part of the smaller top triangle. But now we know what x is, so the y should come out quite nicely from there. On the y triangle, the little top triangle marked in orange here, we've got a 22-degree angle. We've got a 27-degree angle, that's x, which we just found. And we've got the y. But we know all the angles of a triangle have to add up to 180 degrees. So when we add here, we get 49 plus y equals 180. Subtract 49 from both sides, and y is equal to 121. We got a 121-degree angle here in the center of the triangle. There's a second example over here on the right. Very similar. We can figure out missing angles. We're going to need to figure out which triangle we're going to focus on first. Maybe we'll focus on first, let's highlight in yellow our first triangle, the left triangle. It's got a 97, a 44, and a y. So, using that information, 97 plus 44 plus the y, the angles of a triangle have to add up to 180. Well, 97 plus the 44 is 141 degrees so far, plus the y has to equal the 180 degrees. So if we subtract the 141 from both sides, y is going to be equal to 39 degrees. We've got 39 degrees inside that yellow triangle. But we're not done yet. We've still got to figure out w and x. Let's look at x next. X is part of this smaller triangle here, which has the 28, the 39 we just found, and the x. Okay. Then let's figure out what x is. 28 plus 39 plus the x, because it's a triangle, has to add up to 180. Well, 28 plus 39 is 67, plus x is 180. So we'll subtract the 67 from both sides to figure out what x is equal to 113 degrees. We've got one triangle left to look at. It's the triangle on the left, made up of the 124, the 28, and the W. Well, those three angles have to add up to 180 degrees. So 28 plus 124 plus the W adds up to 180. Combining like terms, 152 plus W equals 180. Subtract the 152 from both sides, and W is equal to 28 degrees. And if I erase the highlighting so that you can see a little better, we have now found all three of our missing angles. So the first other property of triangles you need to know is that all the angles of a triangle will always add up to 180 degrees. The second property is close to it. It's an isosceles triangle. An isosceles triangle is a special type of triangle that has two congruent sides. When it has those two congruent sides, it also comes with two congruent angles. Not the one between the congruent sides, but the one down at the bottom from the congruent sides. So the congruent sides correspond with congruent angles, not the between, the ones on the outside. So x and y are exactly the same angle. So I can really call them both x in this example, x and x, because they're the same angle, because we have an isosceles triangle. So x plus that 70 degrees located at the top, that's always the different one, the one at the peak between the congruent sides, we know it has to add up to 180 degrees, because every triangle is 180 degrees. X plus x is 2x's, plus 70 equals 180. And we know how to solve this equation by subtracting 70 to get 2x equals 110. Divide both sides by 2, and x is 55 degrees. These two base angles are 55 degrees. So your second property you need to know is that an isosceles triangle has two congruent sides and two congruent angles. Third property we want you to know, there's four of them today, is the exterior angles of a triangle. If we have an exterior angle of a triangle that's made by extending one of the sides, so we take this one side and we extend it out, that exterior angle, the one on the outside, is always equal to the sum of the opposite two angles. In other words, if I were to take my 40 and 35, that's going to give this exterior angle, x. 40 plus 35 equals the exterior angle, x. X is 75 degrees. Property number 3 is the exterior angle of a triangle is equal to the sum of the opposite two angles. Last thing we're going to talk about with triangles today has to do with their side lengths. Turns out that the sum of two sides of a triangle must always be greater than the third side. Because if the third side is greater, it won't ever be able to close. To be a triangle, they have to be able, the third side has to be smaller than the sum of the first two sides. So if we know two of the sides of a triangle and we add them together, this is going to be the maximum for the third side. And if we subtract them, it'll tell us the minimum for the third side. And actually, it can't be equal to those numbers. It has to be either greater than or less than those numbers. So let me give you an example to kind of illustrate that. We've got a triangle. We don't know what it looks like exactly, but it's got sides 6 and 9. We want to know what range of values are allowed for the third side. Well, to find the maximum value that that third side can be, we add them together. 6 plus 9 equals 15. That third side has to be smaller than 15. So we'll just do it as an inequality here. That x has to be smaller than 15, that third side. But if we want to figure out the smallest it's allowed to be, we subtract them, and we have to put the bigger number first to subtract. 6 minus 9 is 3, which means x has to also be bigger than 3. If x was smaller, like 2, it would never be able to reach that third vertex. It would never be able to close. And if x was bigger than 15, maybe 16, 17, or 18, it would never be able to close either because the last side wouldn't be able to connect. So if a triangle has sides 6 and 9, the third side has to be between 3 and 15. So today we took a look at a couple extra triangle properties to kind of wrap up triangles. Take a look at the homework assignment. Let your instructor know if you have any questions, and good luck to you as you work on these triangles.